Good morning and welcome to session 2 of the Forest Growers Research Conference titled Improving Supply Chain Efficiency, Safety and Sustainability. My name is Chris Barnes and I am the Chief Operating Officer at Hancock Forest Management and a member of the FGR's Harvesting Technical Steering Team. I'll be chairing this session today, which will run from 10:30 until approximately 12:30. There'll be 6 talks with each speaker talking for 15 minutes. Questions and answers will be held to the end of the session. For those that joined the first session this morning, we heard from a range of speakers talking about new product opportunities across both softwoods and hardwoods and how these can add value to forest estates. This session will shift the focus to look at a mix of innovative developments that have been born out of a desire to either improve safety outcomes, such as the automated hauler, or lift efficiencies such as log scaling and tracking projects, improve value recovery by reducing breakage at harvest, or analysing supply chains to identify unique opportunities to improve efficiencies. We will also be given an update on log fumigation status and go-forward options. Now, typically as a chair, we would introduce each speaker before they speak. However, given this unique format, I'll do that now. In this session, we have 5 speakers. Keith Raymond. Keith is the Harvesting Program Leader at Forest Growers Research, and Keith will be presenting 2 topics today. The first, the automated hauler development, and the second, an update on a helicopter/grapple. Our next speaker, Dr. Glenn Murphy from Glenn Murphy & Associates, will provide an update from the Automation and Robotics program, where he's looking at some Swedish technology to replace paper log tags. Our third speaker is Melissa Welsh, who is a postdoctoral fellow at Scion. Melissa has a PhD in economics and will be talking to us today on harvesting, automation, logistics and economics. Rob Preble from Rob Preble Consulting will discuss the effects of using a fixed head felling machine on stem breakage and the impacts that can have on value recovery improvements. And our last speaker is Don Hammond. Don is the chair of STIMBA and has had a long career in forest science and biosecurity and will update us today on methyl bromide and fumigation options going forward. Please submit any questions that you may have throughout the course of the presentations, and then the presenters will join us at the end of the session for live Q&A. And finally, just in wrapping up, I'd like to thank each of the presenters for their presentations today, but also for making this an informative and enjoyable session. I'd also like to thank you for joining the session and making it a valuable day. And with that, I'll now hand over to Keith for the first presentation. Thank you.
Keith Raymond's talk on automated hauler development will start at 10:45 a.m. Until then, Glenn Murphy will give a talk on in-forest debarking. Hi, my name is Glenn Murphy. This morning I am going to give you a presentation on in-forest debarking. This work has been funded by the Forest Growers Levy Trust, the forest industry and the Ministry for Primary Industries. In 2012, Spaniard and Warburton undertook a review of opportunities for and barriers against innovation in 3 New Zealand export industries: forestry, meat and wine. They identified 7 areas for improving innovation and competitiveness. One of these was supply chain restructuring. The in-forest debarking project is about restructuring the forestry supply chain by moving the debarking process from near the end of the supply chain to near the beginning. So why is this important? Bark is a low-value product that adds cost from forest to customer. About 1 million tonnes of bark gets a free ride each year. If we can get rid of bark early in the supply chain, we can drive down costs. For example, if a load of logs fully clothed in bark is transported to a customer, about 8% of the weight is bark About 50% is water, and about 42% is solid wood. If we eliminate the bark, we can also reduce the amount of water in the logs through in-forest drying and increase the amount of solid wood trucked to the customer. Making a change to any supply chain isn't simple. There are disadvantages as well as advantages to in-forest debarking. Disadvantages may include the cost of debarking in the forest, loss of income if wood is sold on a weight rather than volume basis, increased handling and transport costs for slippery logs, possible increases in site preparation costs, increases in landing size, potential value losses due to sap stain, and reduced revenues from bark sales. On the advantages side, there are reduced trucking and shipping transport costs, improved storage at mills and ports, reduced need for fumigation, the potential to eliminate weight scaling, reduced bark contaminants at ports, reduced need for shipping to visit multiple ports, collection, transport and disposal of bark is eliminated, and improved log dimension and quality measurement accuracy. Before we look at purposefully removing the bark in the forest, let's remind ourselves of how much bark is removed through other activities. This photo was taken at the port of Tauranga. The great majority of the bark is still present on these logs. These logs were processed with a motor manual system. This next photo was also taken at the port of Tauranga and on the same day as the first photo. There is very little bark left on these logs. These logs were processed with a mechanised harvesting system. Studies that were carried out 4 or 5 years ago in radiata pine stands found that the amount of bark remaining was greater with manual processing than mechanised processing, in winter than in spring, with cut-to-length systems than in tree-length systems, and with less handling of logs. On average, though, at least 20% of the bark is still on the logs after the stems have been felled, extracted to the landing, and processed into logs. So the next question is, how much bark is there on a stem to start with? On a standing tree, bark makes up 12 to 13% of the overbark stem volume. It varies with height in the stem, with tree size, and with location in New Zealand. It accounts for 7 to 8% of the overbark stem weight. Debarking of logs remains an essential task within the value chain of all timber processing industries. Wood needs to be debarked before it can be processed into further products. When it comes to debarking of logs, what is an acceptable standard? Well, pulping processors prefer 2% or less in the chips they receive. Let's look for a moment at our supply chain and other debarking requirements within the chain. About 40% of our volume goes to domestic customers. Pulp logs have to be debarked to 2% or less by volume to meet the standards. The requirement for domestic saw logs is even tougher. Since it is mostly the outside of a saw log that is converted to chip and sent to a pulp mill, the standard is tougher. Less than 1% of bark should remain on the log after debarking. About 60% of the harvest volume is exported, and 80% of that is sent to China. China will accept debarking as an alternative to methyl bromide treatment. The standard is that no more than 2% of the volume of a group of logs can be bark, and no more than 5% on an individual log. In-forest debarking is one of the projects included within the new Automated Forestry Value Chain Primary Growth Partnership Program. The objective of the project is to develop a low-cost process for debarking logs early in the value chain that meet the required quality standards. The project has been underway for almost 12 months. Waratah and 141 are participating in the project. So what progress have we made? A literature review of promising debarking concepts has been completed. We found that there were many technologies that could be used for debarking. We found that it is unlikely that current processor heads could achieve the debarking standards in an economical manner. And we found that a computer vision plus artificial intelligence system might be able to help determine when the standard has been reached with minimal fibre loss. A concept generation exercise has also been completed. Alternative concepts for one machine and two machine systems have been identified, and the advantages and disadvantages of each concept discussed in detail by the forest owner representatives and the machinery manufacturer's engineering staff. We have developed a structured process for selecting the most promising concept. This process has included determining the selection criteria and attaching importance weightings to them, then making pairwise comparisons of concepts for each criterion, and finally combining the weights and comparison scores to arrive at the best overall concept score. 7 criteria have been chosen for the selection process. These include market potential, debarker operational issues, debarker reliability and durability, system productivity impacts, machine and harvesting costs, overall system costs, and human factors. We have also completed machine, harvesting, and system cost comparisons for each of the concepts based on the best information available. And of course, carried out sensitivity analyses, since for these new machine concepts, we have had to make educated estimates of likely capital costs and productivity rates. The final progress that we have made relates to the computer vision component of the design. Requests for proposals for a bark recognition and sizing system have been sent out. At the same time, we also requested proposals for a knot recognition and sizing system for logs that have been debarked. 3 organisations have indicated that they will be submitting proposals for both systems by the end of this month. The near-term next steps for this project are to finalise the concept evaluation and selection, to review the computer vision RFPs, to carry out system-level economic feasibility analyses. This will be a stop-go point for the project. If the concepts do not look to be economically viable, the project will stop at that point. If it is economically viable, then we will agree on the operating parameters and the design specifications that will be needed to build an alpha prototype of an in-forest debarking machine in 2021. Thank you for watching this presentation on in-forest debarking of radiata pine to improve supply chain efficiency.
Hi, I'm Keith Raymond, Harvesting and Logistics Program Manager at Forest Growers Research. This presentation is about one of the first projects that got underway in the PGP Automation and Robotics program called Forestry Work in the Modern Age. The program is driven by a consortium of forestry companies and New Zealand machinery manufacturers and technology developers and the Ministry for Primary Industries. And it's aimed at automation and robotics across the forestry value chain. The main drivers of the program are to address the issues confronting the industry today, labour shortages that are constraining the growth of the industry. Automating part of a hauler operation means that we can operate a crew with fewer people, so we could split a crew into two and achieve the same production rate. Safety is also a major driver for innovation. We want to reduce workload and take people out of hazardous manual tasks. We also want to reduce the negative impacts on the environment and reduce operational costs. Automation will help us to operate more efficiently with smaller crews and less machinery. And we want to continue to mechanise our operations down the path towards automation. A survey in 2011 of the kinds of cable systems being used in New Zealand revealed that higher productivity systems such as grapples, either mechanical grapples or hydraulic grapple carriages, were not commonly used. Despite this, grapple yarding was known to be very productive, having no hook-on element in the work cycle and therefore shorter cycle times. Grapples don't require breaker outs and therefore are a lot safer to operate. So some of the FGR's harvesting objectives included to increase the use of grapples. To do this, it was necessary to identify and solve the barriers to the wider uptake of grapples. These were identified as their preferred use with swing yarders, capital cost and the risk of damage, the need for greater visibility by the operator, difficulty of operating a grapple yarder, and the need for a skilled operator, and greater skyline control required to raise and lower the grapple to load and unload. So we needed to explore options to solve these issues or barriers. Solutions were seen as a grapple that operates on a tower hauler, ground proximity sensing and collision avoidance, camera systems for better visibility for the operator, easier operation through joystick hand controls, and hydraulic control of the skyline. Looking at our current hauler operations, one of the challenges is to improve hauler grapples from dumb mechanical grapples to smart grapple carriages. This means converting a grapple carriage from a totally manual operated grapple to what we call a smart yarder grapple, incorporating elements of automation and a new hauler control system. The vision for the semi-autonomous hauler control project fits the PGP program vision of no boots on the ground, no hands on the log. With features such as automatic carriage return to the last breakout point, stem recognition where the grapple uses machine vision to identify the next load, automatic lowering of the skyline and positioning of the grapple on the stem, auto return to the landing, controlling skyline tension and ground clearance. This requires better hauler control systems to raise and lower the skyline by hydraulics rather than mechanical winches, and auto stop at the landing edge, lowering the skyline and landing the load. In September 2018, Lars Rosewarne of Rosewarne and May in Whangarei, developers of the remote-operated bulldozer winch assist system, approached Raionier Matariki Forests and Hancock Forest Management with an idea to develop an automated grapple system for tower hauler logging. Matariki and Hancock were both keen to support the project as an industry-wide project. An initial project meeting was held with Rosewarne and May in November 2018, where the initial scope of work was proposed. FGR decided to allocate funding towards this development project as it closely aligned with the Smart Yard Grapple and a semi-autonomous hauler control project in the PGP program. The new automated Grapple project had a budget of 1.273 million that comprised design and build of the alpha prototype Grapple and hauler for 1.125 million, and that's made up of purchase of the hauler components and spare parts, design and build of the Grapple carriage and hauler cab, and initial testing. In year 2, there is a budget for an additional 148,000 for field trials, industry demo and commercialisation. The contribution of each of the partners in the project is roughly 20%. For Rosewarne and May, the 2 forestry companies together, and FGR. The balance of the project budget, 40%, is made up from MPI cash. The development of the automated Grapple system will eventually include the improved motorised Grapple carriage, hydraulic skyline control for the tower hauler, development of machine vision for the Grapple carriage, and commercialisation and deployment. Rosewarne and May will be responsible for all warranties once the product is commercialised. The intellectual property is all existing IP owned by Rosewarne and May. Design was completed in December 2018. The forest industry funding was gained over a period of 6 months, and a second-hand hauler was sourced in October of 2019. The completed Grapple and hauler control system will be owned by Rosewarne and May Limited and used as a swap machine for the next adopter contractor to use while their machine has been retrofitted. It was estimated that construction would take 12 months, but the COVID-19 shutdown has delayed progress. Construction began with replacing the electrical system and fitting a new air control system to the second-hand Thunderbird TTY70 tracked hauler. An update on the Yada construction. The Yada is now being painted and assembled, and once painting is complete, the tower will be fitted and ropes installed. A problem has been identified with a faulty hydraulic motor on the skyline drum, and that will be replaced under warranty. An update on the Grapple construction. Construction of the Grapple carriage is now complete and it's being assembled. Wiring for the remote control system is now being done, and completion is expected within 1 month. The next steps in the project: the hauler refurbishment will be completed later in October 2020. An RFP process is underway for STEM recognition, which will run from October through to December of 2020, and field testing will be undertaken from November 2020 through to February of next year.
Kia ora. This is Reen Visser here at the School of Forestry, University of Canterbury. And while you're waiting for your next FGR conference speaker, I've been given the opportunity to spend a few minutes just promoting our professional development courses that are coming up in the 2nd to the 4th of November in Rotorua. So normally we would have held them here on campus, at least we have for the last 4 years, but in this case, assuming you're up in the North Island, we're coming to you, so up in Rotorua. There's 3 one-day courses that will run consecutively, so Monday, Tuesday, Wednesday. And just to share a little bit more detail about those courses. So the first course that we have is on how to determine a fair logging rate, or basically setting your logging rates. It's invariably a very difficult, potentially contentious process, but obviously it's critical for the financial success of both the forestry company as well as the contractors. So some of those key elements that we'll be covering is calculating machine system costs, as well as estimating productivity for a given system at a given site. We'll also be exposing you to the benchmarking, the FGR benchmarking database, and how you can best use that database to capture both cost and productivity information. And then also we'll focus on how to negotiate, how to best negotiate a logging rate and what some of those different negotiating practices are. Very fortunate to have Keith Raymond join me as instructor for this particular course. On the Tuesday, looking at designing stream crossings, obviously critical to protect our waterways under the Resource Management Act. Be providing an update on forest road construction practices, look at some of those main stream crossing design considerations, teaching you how to calculate flood flows using different methods, and using those methods to also design your culvert, as well as get the size of your culverts right. That's assuming you're building a culvert type crossing, but we'll also really be focusing on your bridge options, and tends to, in that it's often best to go over a waterway than it is to stick a culvert in a waterway. So we'll be looking at the advantages of some of those modern bridge options that we have. Finish off by looking at some of those new capabilities in RoadEng, latest software that's out there, and it includes being able to design landings in there, designing spur roads, as well as there's a new module available in RoadEng 9, which is cable logging planning. So you can actually do your cable yarding analysis within RoadEng now. Campbell Harvey is going to help instruct that, as well as Dean Nielsen from Hancock, a true expert on designing stream crossings. The last workshop is all about managing harvesting residues. We know that these accumulations are both a risk, but they also present a real value opportunity for our industry. So we'll be stepping through some of the definitions, understanding the issues, studying the existing guidelines, as well as looking at some of the effects that your choice of harvesting system and harvesting practice can have on the generation of harvesting residues. Finish out by looking at biomass marketing opportunities and showcase some of the successful case studies that we've done. Again, it's myself, Campbell Harvey, and Keith Raymond will be bringing in some of the FGR research work, like the helicopter grapple, as well as the fixed head felling study that they have been directly involved with. So if you're interested, how do you sign up? There is a cost involved. It's $300 per person per day to cover our costs, or it's $820 if you want to come to all 3. You just need to email me. I'll put your name on a list. And then if you turn up, we'll send you an invoice. But also please be aware that if Rotorua does go back up to COVID level 2 or higher, we will be postponing the event. So we're only going to invoice afterwards to avoid any sort of complications. So if you're interested, please do email me. We certainly look forward to seeing you there. Nice to get together and share some good information. Thank you for your time. Bye.
Good morning. The Automated Log Tagging and Tracking project is part of the Automation and Robotics PGP program, which is managed by Forest Growers Research. The project started last year and is expected to be completed by the end of 2025. This morning, I will give you some background to and a brief progress report on the project. For some parts of the world, the question is, why tag logs? This question doesn't apply to New Zealand. More than 60% of the roundwood produced in New Zealand is exported as logs, and these logs are all scaled and paper tagged at inland or marine ports before they leave the country. The question for us is, where should we tag the logs? This project is about tagging in forest so that the benefits can be obtained earlier. I don't have time this morning other than to highlight a few of the benefits of tagging and tracking. These include improved health and safety, forest to mill supply chain efficiencies, improvements in mill recovery and profitability, improved handling and control at ports, traceability and chain of custody, and an opportunity to target genetics and nutrition by site and aspect. Between 2000 and 2010, the Europeans carried out a very large project called the Indisputable Key project. It looked at a wide range of potential tagging technologies, from paper tags to biometric fingerprinting to DNA analysis. Here are the top three contenders. One was radio frequency ID tags. They got to the stage of building a prototype on a harvesting machine. A tag from a canister was punched into the end of the log. Problems with consistent tag readability and with costs were issues with this technology. Another top contender was inkjet printing of logs. The Woodland system is a commercial solution today. A stand ID, but not a log ID, is sprayed onto the log end. The Indisputable Key project earlier tried spraying a QR code on the log end through holes in the chainsaw bar, but this didn't go any further. The third contender was a punch code system. It is a refinement on a technology that is at least 200 years old called branding hammers, except that the symbols can be changed for every log. A solution about the size of a credit card is under development. Let's take a sidestep for a minute and look at the cost of tagging. Let's assume that a tag costs 10 cents per marked log. The cost per cubic metre will obviously depend on how big the log is. Long fat logs would cost 10 cents per cubic metre. Short skinny logs would cost close to $2 per cubic metre. Now let's look at the cost of the different tagging solutions for a 200mm small end diameter log that is 3.6 metres long. Passive RFID tags bought in bulk may cost 30 cents each. That equates to $2.25 per cubic metre. In comparison, inkjet tagging costs about 2 cents per tag, or about 15 cents per cubic metre. And punch code tagging has a nominal cost of about 0.4 of a cent per tag, or about 3 cents per cubic metre. I'm sure you are not surprised that the technical steering team for the Robotics and Automation program recommended that FGR proceed with the development of the punch code system. Comparatively low cost, no consumables, and extremely large numbers of logs that can be uniquely tagged are features of this system. With this 12-symbol, 16-position code on the left of your screen, we can uniquely tag over 280 trillion logs. Otmetka, a Swedish company, own the IP for this technology. The objectives of the Automated Log Tagging and Tracking project are to design, develop, manufacture, and commercialize an automated log tagging, tag reading, and log data storage system. Implementation of the tagging solution will be carried out on an in-forest Grapple processor and at a central processing yard. If the project is to be successful, it will have to satisfy the tracking needs of participants right across the forest to log customer supply chain. It will have to operate effectively in harvesting operations and trucking operations, in satellite yards, in marine ports, and mill yards. The goal is to design and manufacture tag applicators and fixed and mobile tag readers. As part of the system, we will also be developing blockchain data storage and management capability. Testing of the system will be carried out in harvesting operations, a satellite yard, a mill yard, and at a port. So what progress have we made? COVID-19 has certainly pushed our timeline backwards by several months. However, a work plan and budget have been prepared, and the project team has been established. We have 5 forest companies so far committed to the project. 3 of these are integrated companies with mill operations. We have the 2 biggest port logistics companies in the team. We have a Grapple processor manufacturer on the team, plus a company that will develop the tag reading equipment. Importantly, Otmetka has also established a subsidiary here in New Zealand and will be participating in the project. Our goal is to have developed and built and tested both alpha and beta prototype versions of the applicators and the readers by the end of 2022. There are some provisos to our goal, of course. The first proviso is that the proof of concept must be successfully completed for both applying the tag and being able to accurately read the tag. The second proviso is that the concept must be economically feasible. The benefits of tagging early in the supply chain must outweigh the costs. 2 sets of testing have shown that a code can be generated, passed to mechanical equipment, and applied to a log end. One of the demonstrations was with technology that could be fitted to a harvesting machine. The other was with a simple but automated hammer. Another proof of concept test showed that computer vision could be used to find the punch code symbols on a log end and convert them to an ID code. This test completed the tag generation, tag application, and tag reading circle. The next short video clip shows a code being passed to the mechanical equipment and the code being stamped onto a log end. On the left-hand side, you will see the code symbols rotating to the new generated log ID. The Swedish proof of concept tests were carried out under laboratory conditions. The New Zealand proof of concept trials are being carried out under a wider range of conditions that are likely to be encountered in New Zealand. We want to determine the effect on readability of log-in conditions, time since application of the tag, treatments such as anti-sat stain treatment, lighting conditions, distance from the camera to the log end, angle of the camera to the log end, weather conditions, and species. The tests will allow us to determine under what conditions reading works best, how much gain in readability can be gained with improvements in different hardware and software, and what changes might be needed to work methods to optimize its performance. The first steps in determining the economic feasibility of tagging with the punch code system has been for our stakeholders in the project, that is the forest owners and port logistics companies, to map the forest to customer supply chain and to mark where in the supply chain they would read a tag if one was on a log. The supply chain is complex and there are many locations and activities where tag reading could take place. For example, stakeholders identified 4 places in a transfer yard where tag reading could take place. The different coloured eyes represent different stakeholders. The next steps will be to attach costs and cost savings from tagging logs to the activities in the supply chain. As mentioned earlier in this presentation, 60% of New Zealand's harvest volume is exported as logs. Those logs are all measured using the Japanese Agricultural Standard, or JAS, volume measurement system. JAS is based on diameter measurement of the small end of the log. This has been raised as an issue by the stakeholders group since the tag will be placed on the large end of the log. Processing of stems into logs is carried out big end first for delimbing, value recovery and breakage minimisation reasons, so it is more efficient to place the tag on the big end. Luckily, when a saw cut is being made, the big end of one log is the small end diameter of the log that has been cut before it. There are a number of different ways that the diameters of the small end or large end, whichever way you want to look at it, can be determined, including vision-based systems, harvester head measurements, or scans when the log is delivered to a mill. Further work is planned to address the JAS measurement issue. Finally, I would like to briefly mention collaboration that has begun between New Zealand and Australia. The University of the Sunshine Coast has just started a new supply chain innovation and optimisation research program. It is funded through FWPA's current research investment plan. The focus of their program will be on new sensor systems for measuring and improving value capture, and on automated tagging and tracking of logs. I've been asked by USC to lead their project as well as the FGR project over the next 2 years. More information on New Zealand's tagging and tracking project will be put on FGR's website as it becomes available.
Sustainable planted forests. They're a natural tool to soak up atmospheric carbon in trunk and building. Forests protecting our fragile landscapes and cleaning waterways. A habitat of choice for many of our endangered wildlife. Love our forests.
Good morning, everyone. My name is Melissa Welsh from Scion. I'm going to be presenting to you a bit this morning about the logistics and economics around harvesting automation. So also involved in this project with me is Karen Bain and Oscar Montes, also from Scion. Ha is a master's student from Massey University who's been quite involved in some of the extensive modelling we've done with this project. And Robert Radix from Lincoln University has also been quite involved initially in the setup of this project and helping us carry on in some of the validation process. So a bit of an overview of what this project is about. So we're looking at the current harvesting process and introducing a new harvesting process which is more automated, along with a robotic sort yard. So we're taking, instead of leaving so many logs on the landing, they're just sent directly to the sort yard and sorted there and taken to the port or the pulp mill or the mill. So this is reducing a lot of the logs stacked up on the landing, which is a nice health and safety benefit, as well as increasing the efficiency of log throughput. So this is a diagram of what the conventional ground-based process looks like. And this is an automated version of the ground-based harvesting process. So some of the differences here to highlight is we're reducing the number of chainsaws involved, essentially removing them from the process altogether, but there may be one left on site as a just in case. The Grapple processor is being replaced with a processor debarker, and we're also introducing an automated chipper to the landing so we can process trip and remove slash, etc. that might be on site as required. And then along with that, we're also introducing a chip truck which takes that chipped material to the pulp mill. Another benefit of this is that the conventional ground-based process involves 7 personnel, while in this new automated process, we are able to reduce that to 5 people needed on the landing site. So the mechanized hauler process is illustrated in this top diagram here, while the automated hauler version is shown down the bottom here. So again, we're reducing the number of chainsaws involved. Our metal swing yarder is replaced with a semi-automated metal swing yarder. And this Grapple processor loading area loader process is now being replaced with a processor loader debarker. So that's all happening with one machine rather than 2 or 3. Again, we have the automated chipper to deal with our chip on site on the landing. And this conventional process in this case involves 9 people, while the automated process only requires 4. This is a diagram of what the sort yard looks like. So we've got our truck unloading to the which loads onto the log sorter, which excludes a debarker because the debarking is now happening on the landing site. And those logs are then either loaded directly onto the log truck loading gantry to be sent off to where they're going, to the port or the mill, etc. Or they're put into log storage to wait for the truck to be available for them to be loaded onto. So all of the logs that are waiting around in storage are now waiting down at a sort yard rather than up on the landing where all of the harvesting is going on. So look at how the trucking is changing in our new automated process. So the current process, we have logs going straight from the landing site to either the mill or the pulp mill or the port. Whereas in our new process, all of these logs go from the landing to the sort yard. So they're all going to the same place as soon as they're harvested. We don't have to sort them on site to figure out where they're going to go. So they're sorted at the sort yard and then sent to the pulp mill or the port. And another benefit here is we can use the best trucks appropriate for where the material is going. So from the landing to the sort yard, we can use tracks that are optimised for transport within the forest. There's going from the sort yard to the final destination. We can use tracks that are optimised for transporting logs on the road. So just a quick side-by-side comparison of the two models. So we have our 3 conventional ground-based crews are being replaced with 3 automated ground-based crews. Our 2 conventional hauler crews are being replaced with 2 automated hauler crews. Our 1 conventional 2-stage crew is being replaced with an automated hauler 2-stage crew. And we have 2 conventional mechanised hauler crews being replaced with 2 automated mechanised hauler crews. We've also introduced the sort yard to our automated model. And the number of people involved has gone from 64 workers in the conventional model down to just 53 in the automated model. So this is a picture of what the simulation process looks like in XtendSim, just to give you an idea of what we're working with. And this here is just a short video of starting with the ground-based crew harvesting process and then moving into what the tracking looks like. So this is everything going directly from each landing site to the port or the pulp mill or the mill. And by comparison, this is the new automated tracking process. So everything is going from each of those sites directly to the sort yard and then is sorted at the sort yard. And this is a close-up look of the automated ground-based harvesting process. And then we'll scroll up and have a quick look at some of the inputs and data that are used to run the model. So we've also been doing some validation of our simulations of the conventional harvesting processes, that is, because the automated processes don't yet exist for us to look at real-world data. But we've been using the benchmarking data provided by the School of Forestry at the University of Canterbury. So they have 1,600 unique entries from over 12 years of harvesting. And they've been able to provide us with annual summaries of various operation types. And we've been using the best operational match to validate our simulation outputs. So this is a table comparing our simulation outputs in tonnes per days with what the benchmarking data suggests is really happening. So overall, things look to be fairly consistent with reality. The biggest difference we notice is here with our swing yarder 2-stage skidder. It's still well within the 95% range. However, there's no distinction made in the type of 2-stage harvesting happening in the benchmarking data, while we're specifically in our model looking at the swing yarder. But this gives us an idea of how much we can trust the simulated automated operations. So if our simulations of existing operations are fairly consistent with real-world data, which they seem to be, then we should be able to be fairly confident that our automated operations are also going to produce an accurate picture of what will happen in the real world. So this is a summary of financial measures looking at a 20-year period. So comparing our current harvesting processes with the new proposed automated process, we can expect a nice increase in the net present value. So going from 5 million to 85 million. Our return on invested capital increases from 7% in the current process to 24% in the new process. And the payback period from investing in setting up a current process versus a new process goes from 14 years down to just 4 years in the new process. So the costs of setting up are higher in the new automated process. The machinery is a bit more expensive to purchase initially. And our total startup cost is also increased. But our annual labour costs are decreased as we're decreasing the number of personnel. So we're going from 5.1 million per year down to 4 million per year spent on labour. And our trucking costs per tonne are also decreased. So instead of $8.10 per tonne, we're down to $5.90 per tonne. And our total cost per tonne of logs produced is actually going from $40 per tonne down to just $23 per tonne. And we're also increasing the throughput in this process as well. So rather than processing just 230,000 tonnes per year, we're able to increase that to 420,000 tonnes per year. So we have decreased our operation costs and increased our revenue. Just a summary of everything I've spoken about this morning. So we're comparing the proposed automated harvesting process with current practices. We've developed simulation models using XtendSim, comparing 4 existing harvesting operation types with 4 corresponding automated operations that have been proposed. And the results have been an increase in system throughput. We've also conducted some validation of the models using benchmarking data and developed an economic model to assess the costs and benefits of automation. So we've seen that we can increase the revenue and decrease the operation costs. And some of the next steps is we need to undertake some sensitivity analysis to identify some of the factors that are important in driving this benefits from automation and some of the break-even points involved as well. And we're also looking at bringing forestry companies on board to use company-specific data. So, and to develop mathematical optimization process so we can identify the best combination of automation for a specific company. And we're available for customizing the model to your harvest operation if you're interested in being involved. So thank you.
The time to stop runaway global warming is running out. Fast-growing forest trees are the most effective way at this time for us to fight climate change. They suck carbon from the atmosphere. That's a big environment plus, and there's more jobs and income if you grow trees than farming sheep and beef. That's why so many smart farmers are so bullish, planting out trees and loving our forests.
Hi, I'm Keith Raymond. This presentation is all about reducing the negative impact of harvesting operations on the environment. One of the major opportunities facing New Zealand forestry in the next 10 years, to which R&D can contribute, includes demonstrating sustainability in terms of soil conservation, water quality, peak flood control, and reducing debris flows. There's no doubt that images such as this from 2018 are seared into the memory of the community at large. Children today still ask, why are you putting logs on our beaches? As an industry, we're under attack for damage to neighbouring property from debris flows. Since the dramatic events of Cyclone Gita in Tasman Bay in February 2018, and the high-intensity localised storm in Tolaga Bay in June of 2018, the industry has been developing some responses in terms of near-term management actions, focusing on addressing some of these issues. As we know, the build-up of slash, which is woody debris from wind-thrown trees, broken tops and branches, and residues from harvesting operations on the cutover in steep forested areas adjacent to waterways, creates the risk of blockage of those waterways and mobilisation of debris downstream during high-intensity rainstorms. From a harvesting perspective, we need to improve our harvest planning to increase the scale and time frame of our planning to extend the time period over which we harvest high-risk catchments. Secondly, we need to continue to develop mechanised harvesting operations that reduce tree breakage. And thirdly, we need to develop new technologies to better extract harvesting residues. Doing nothing or the same old is not an option for the industry. On the subject of improved harvest planning on a catchment scale, FGR published a paper in the Journal of Forestry on steepland forest management lessons from 25 years ago, drawing on experience in developing a long-term catchment level harvest plan in the northern boundary of Kaingaroa Forest. In the area of felling practices, this presentation and the next one by Rob Preble focuses on harvesting operations to better clean slash out of streams and in preventing material getting into streams in the first place through reducing tree breakage during felling. As a result of a workshop on the management of erosion-prone forests in August of 2018, FGR commenced a number of projects to find ways that the forest industry can improve its environmental management performance. One of the projects from the workshop in 2018 was to investigate alternative means of slash removal from sensitive areas, such as an improved grapple that can pick up slash, branches and tops from incised gullies and waterways in steep terrain forests. Forest industry stakeholders supported the project to improve extraction of forest residues, which was aimed at designing, building and trialling a helicopter slash grapple. It's a collaborative project between FGR, Helihawk Limited, Wairarapa Helicopters and PF Olsen Group. And it's funded by the forest industry through the Forest Growers Levy Trust outside of the PGP program in forestry automation, co-funded by MPI. The slash grapple was designed by Helihawk Limited of Taupo to have a maximum grapple opening of 1.45 metres and weigh as little as 76 kilos. It has the option of attaching a third tooth or tine between the two main tines on each side of the grapple. The build commenced in March of 2019 at Colchester Engineering Limited in Matamata, with the attached inner pack hydraulic unit, which you can see on the slide to the right, comprises the Kohler engine and a variable volume reservoir and hydraulic pump, and all up the unit weighs about 200 kilos. The slash grapple was designed to be matched to the lifting capacity of the Squirrel helicopter, which is about 1,000 kilograms. After it was built, the first production field trial of the Helihawk slash grapple was undertaken in Gisborne in May last year. The versatility of this helicopter allowed it to carry an effective payload of 750 to 800 kilos of slash per load and to be able to fly into deeply incised gullies and land on very small landing areas. The helicopter contractor undertaking this trial was Wairarapa Helicopters Limited, based in Masterton, and the pilot was Tim Williams, a very experienced pilot. In terms of the results, under the best conditions of fresh slash and no logs in the slash, the cycle times averaged just over 1 minute, and the productivity averaged 18.5 tonnes of slash per hour. The cost of slash extraction averaged $135 per tonne of slash removed. When the cost of the helicopter operation was divided by the volume of wood that was extracted from the harvest block, the cost averaged $1.05 per tonne of wood produced. A lot was learned during the trial on how to pull the slash out of the stream most effectively. The key to productivity is not flying the slash too far for rapid turnaround. Pulling any large logs out first with a logging grapple before extracting the slash, then the average extraction productivity of the slash grapple was highest, and extracting fresh slash, which holds together much better than old, dry or rotten slash. So in conclusion, using manual workers to remove harvest residues from steep or incised gullies can readily be recognised as a dangerous task. Sending machinery down into gullies close to waterways to remove harvest residues, while it's effective, often results in soil disturbance that destabilises the stream banks, increasing the risk of bank collapse and the sedimentation of waterways. The helicopter was able to extract slash which would be high cost and hazardous for manual slash extraction, which is the more traditional method of stream cleaning. The implementation of safe and efficient helicopter slash extraction substantially reduces or eliminates the unsafe nature of manual stream cleaning and minimises the risk of negative environmental outcomes. Now the pilot has had more experience with slash extraction and the most productive conditions are known, which is fresh slash and fewer large buried logs, the productivity has greatly improved and the cost has been reduced significantly. The latest trial has been in a small farm forestry block in the Wairarapa, and we took the opportunity to shoot this video of the operation.
The forest industry in New Zealand recognises that it needs to improve its environmental management performance. Woody debris or slash from forests on steep terrain can wash down waterways, causing problems downstream. Removing this slash after harvest has traditionally been difficult, which is why Forest Growers Research is managing a project to develop better ways of extracting the residues that arise during harvesting steep forested terrain. The slash grapple, designed by Hallihawk Limited and built by Colchester Engineering Limited, was trialled in various steep terrain forests in the Wairarapa and Gisborne regions, using a skilled pilot from Wairarapa Helicopters Limited.
Sarah and I have been farming here for 30-something years and planted a lot of this forest 20-something years ago, and we've been mindful of trying to harvest it as tidily as we can, which is quite difficult. We were not too keen about the slash getting in the waterways and ending up causing issues further on downstream, and so having this grapple is going to hopefully remove a lot of that stuff that's going to cause problems.
And P.F. Olsen's approached me about using our conventional grapple for moving the slash out of the stream. So what they told me they wanted to do, I said, well, our other logging grapple just wouldn't meet the do the job. So I rang Tim and says, gee, we've got to have a look, what are we going to do? We knew we had to make a grapple that would pick up the slash multi-time, but also to release it in flight, to speed up our turnarounds. So that's why we're running a hydraulic Enerpack, so you can let it go in mid-flight.
Ronnie rang me up one day and said, we've got to get a grapple made, a slash grapple. And I said, yeah. I said, yeah, I'd be interested in that. And away we went. And hence the reason we're out here doing it today. And we're here on a block on the Wairarapa coast, and it's a good block to do the trial on. It's a pretty difficult thing to fly because it moves in 3 places. But once you get a bit of a handle on it, it's it works extremely well.
It certainly does make a difference on what we've seen with our trials and everything, and we can target the places where they can't get with the diggers and things like that. So that's the sort of the channel we're heading down, isn't it, Tim?
Yeah, we're just another tool in the toolbox for a forestry company. When it's a flat, it's fine, you know. But when you've got steep banks that lead into it, that's where the machinery starts to
get down there.
Yeah, we can go in there. We just pull what we have to pull out, and we're gone.
Got a 7 horsepower Kohler engine with its hooked to our hydraulic pump. And we imported a VVR hydraulic unit from America, which is a pretty innovative idea that's allowed us to cut our oil capacity down to save weight, and this actually pressurizes. It runs under 10 psi pressure, which is feeding our pump, so we get no cavitation or anything with this swinging around. And it was enabled us to keep the weight right down. It's a new idea that they've made. That's the only one in New Zealand that I know of, and it's a pretty innovative idea. So far it's been working really well. It's awesome.
helicopter/grapple works well in difficult operating conditions, in areas that would be too difficult and dangerous to clear with either machines or manual labour. The grapple works best clearing slash which is fresh in the first few months after harvest. It is a new tool in the toolbox for forest owners to use for improved residue management, and moving forward, it is definitely part of the solution for high-risk environmental areas such as steep terrain waterways.
Good morning. My name is Rob Preble from Rob Preble Consulting Limited. I'm currently working on a few projects for forest growers research in the Automation and Robotics program. In a recent project, Forest Growers Research undertook to determine whether a fixed felling head could reduce stem breakage during felling. Localised debris flow from severe weather events in forest catchments was the cause of significant damage to downstream properties in the Nelson and Gisborne regions during 2018. You may recall that these events made national news on several occasions. There was widespread public concern about forest harvesting practices, particularly stem breakage during felling operations. Forest Growers Research produced a work plan to quantify the effects of different felling heads on the amount of stem breakage. The objective of the project was to compare the breakage from a feller director, commonly known as a dangle head, with that of a feller buncher, better known as a fixed wrist or fixed head. The feller buncher used in this trial was a Timber Pro TL765D, fitted with a KF 800 felling head, owned by Mechanised Cable Harvesting Limited in Nelson. This 43-tonne, 255 kilowatt machine is manufactured by Rosen Developments in Australia and marketed by Komatsu Forest in New Zealand. The KF 800 head has full 360-degree rotation and can tilt forward up to 90 degrees. It has a 40-inch long chainsaw bar which can rotate out 180 degrees to enable scarfing the trees without having to move the base machine. The head weighs 3.5 tonnes. The feller director used in the trial was Mechanised Cable Harvesting's John Deere 909 self-leveller with a Satco 630 dangle-type felling head. The study site was a block of 28-year-old radiata in Tasman Pine Forest's Wairero Forest in the Nelson area. It was a ground-based setting with an average slope of 21 degrees. Unfortunately, operational constraints prevented the observation of the dangle head actually felling the trees in the trial site. So a similar machine with a Waratah L95 felling head working in a nearby fire damage stand was used to collect activity sample data. The sticks data from the trial site was still able to be used to compare breakage. Average piece size was around 1.3 cubic metres, mean tree height was 38 metres, and the average diameter was approximately 36 centimetres. Machine utilisation was established using activity sampling at 30-second intervals. The sticks harvesting software was used to compare breakage between the two machines. A sample of trees were manually measured to verify results from the sticks analysis and to try and determine the cause of stem breakage. A total of 1,381 stems were harvested in the trial. Have a look at the following video clip and take particular note of the tree in the vertical position above the center of the machine as it slews around, the upwards curve of the tree as it falls towards the ground, and the soft impact of the stem as it hits the ground. From the sticks data, on average, trees felled with the fellow director, represented by the blue bars on this graph, broke at 22 centimetres, while trees felled with the fellow buncher, shown by the orange bars, broke at 16 centimetres. This was a 27% reduction in small end diameter. Using the same colour scheme from the sticks analysis, this graph shows the average merchantable stem length for the John Deere was 16 metres, while the Timber Pro was up to 22.5 metres. That is a 40% increase in merchantable volume. A small sample of stems were measured after felling but before extraction in the Timber Pro trial area. Trees felled uphill broke at 89% of mean tree height, while trees felled across slope broke at 92%, and trees felled directly downhill broke at 76%. Although the sample was small, this shows that stems felled across slope and uphill were longer and broke at smaller SED than stems felled straight downhill. This slide shows a breakdown of the felling cycles for the two machines. Remember that in this instance, the John Deere in the right-hand graph was working in fire-damaged trees. You can see that 84% of the Timber Pro's cycle time was spent actively felling trees. This is represented by the dark blue, red, green, purple, and light blue wedges. The remaining 16% of its time was spent clearing access to the trees and repositioning. But it should be noted that there was significant amount of wind throw in the trial area. By contrast, around 90% of the John Deere's felling cycle was spent actively felling trees, and the remaining 10% was clearing debris to gain access to them. The fixed head machine felled 70 trees per hour, whereas the dangle head felled over 100 trees. But the condition of the stand will have had some influence over this result. A closer look at the graph shows that 39% of the fixed head cycle was spent felling and slewing with the tree vertical, the blue and red wedges. Compare that to 26% for the dangle head. By contrast, the dangle head operator spent a quarter of his time bunching stems after felling, whereas the Timber Pro operator spent just on a fifth of the time bunching. This is represented by the green wedges. Overall conclusion, the proportion of time spent on each component of the felling cycle was similar for both types of felling head, but the condition of the trees in the stand did have an influence over the elements in the felling cycle. The sticks data showed that the fixed drift felling had definitely reduced the amount of stem breakage occurring during felling. Thank you very much. I look forward to your questions.
Good afternoon, everyone. Thank you for the opportunity to talk to you this afternoon. I'm Don Hammond, Chairman of STIMBA. STIMBA is the Stakeholders in Methyl Bromide Reduction. I'm Chairman of the Board, and my intent this afternoon is to give you a brief update on some of the work that STIMBA has been doing over the past 12 months, and also to highlight some issues that we see facing the log export sector. So I'm going to talk about the issues facing the log export trade, in particularly post-2020. The background to this is that STIMBA has been working for the last decade, since the 2010 EPA decision requiring 100% recapture of methyl bromide as of October 2020. The work STIMBA has done can be broadly broken into 4 phases. The first 2 had largely been completed. We've decided what research we needed to do. We've completed some very, very focused and detailed and internationally respected research. The second 2 phases were around gaining approval through the various statutory processes in New Zealand, and also gaining approval from our trading partners. The final phase was the transition to new fumigation and other technologies and implementation of that. Unfortunately, while the first 2 phases have gone very well, we have been, as many others in this country have, been stymied by the regulatory process and its glacial pace of movement. So this afternoon, I'm going to talk briefly about methyl bromide, about EDN, dual heating and debarking. Just to recap, our current harvest in New Zealand is around 35 million tonnes a year, and we believe that it's going to stay around this level for the foreseeable future. There will be some movement up and down due to market response and so on, but it will be in this sort of order. 60% of that harvest, around 21 million tonnes, will be exported as logs, and of that 21 million tonnes, currently 70%, moving towards 80%, will go as logs to China. Our other key markets, India, Korea and Japan, and a few smaller markets that are evolving. India and China both require either fumigation or risk reduction measures before logs can be exported to them. Turning to methyl bromide, there are a number of moving parts. I want to talk briefly about the judicial review process we implemented, the waiver that we've worked through, the reassessment process, the consents for genera, who are largely the only fumigator available to the log export trade, and some update on lower application rates of methyl bromide. In 2019, STIMBA filed for a judicial review of the 2010 hearing in the High Court. That review sought to challenge the decisions that were made in 2010, even though it was 9 years after the event, because it had only just become apparent that those requirements, those decisions, could not be achieved. That judicial review has been put on hold several times to allow the reassessment process to proceed, and in part because the EPA had promised the court that we would have a decision by Christmas last year. Because the reassessment process has continued to operate, that judicial review application has now been withdrawn by agreement between the 2 parties, the EPA and STIMBA. Instead, STIMBA sought to get a waiver of the 2010 decision that 100% recapture was required from October 2020. The court has granted that waiver, and so now we have until the end of April 2021 before those recapture requirements become mandatory. STIMBA will be seeking a further waiver, likely to be late this month or early next month, unless we can see some rapid progress on the reassessment process that is underway. So I guess that's code for we'll be filing for a further waiver. We've also been working on lower application rates of methyl bromide. Part of our philosophy was we may not be able to move away from methyl bromide, but can we use a whole lot less? And we have done the science that will show that we can use considerably lower rates, and that could result in a reduction of around 40% of our methyl bromide use. To give you some perspective, we currently use around 600 tonnes a year. That would immediately reduce that consumption by somewhere in the order of 250 tonnes, a very substantial change. We've proved that this lower rate of methyl bromide does work in confirmatory tests at a commercial scale, and we have been negotiating with our trading partners to gain approval to proceed with this. Unfortunately, of course, the pace of that decision rests with our trading partners, not with ourselves.
Stimba filed for a reassessment, or filed a reassessment application for methyl bromide in March 2019. The EPA, through our judicial review process, advised the court that a decision would be available before Christmas 2019 and initially opposed the judicial review on that basis. However, the hearings for the reassessment were not actually carried out until August 2020, and subsequent to that, the decision-making committee have asked for even more air dispersion modelling with no timelines or deadlines attached to that. Furthermore, the EPA is proposing buffer zones that are completely unworkable, and so we're in a situation where one unworkable control that was in the 2010 decision around recapturing 100% of the methyl bromide is to be replaced with a different but equally unworkable control around buffer zones in the 2020 decision. Again, as noted, there's no timelines provided by the regulator, either the DMC or the EPA, and this clearly creates uncertainty and confusion. Genera's consent for the use of methyl bromide expired in early 2020. So back in November 2019, Genera applied for a new consent, and by applying back in 2019, this allowed them to continue using the old consent until such time as the new one is heard and decisions are made. Once again, there is no timeline provided by the regulator, even though the Act imposes timelines. The Bay of Plenty Regional Council have invoked various parts of the Act that allows them to drag this out for as long as they choose. Genera need time and certainty to invest in additional recapture equipment, and that is simply not available at the moment. Moving on to EDN, a registration application was filed in July 2017. Yep, that's over 3 years ago, and hearings were held in August 2018. Safe work instruments, a responsibility of WorkSafe, have been developed as required under the new Health and Safety in the Workplace Act of 2015, but to date they are still sitting within WorkSafe and are yet to go to the Minister for sign-off. Again, there is no delivery of a timeline of when this might happen and when decisions will be made, and you kind of suggest that there's a theme starting to emerge that nobody is willing to commit to any timelines. EDN has been, there are proposals for EDN to be used in trial shipments from Australia to China. This is quite a positive move because it indicates that both the Chinese and other log exporters are exploring the use of EDN as a possible alternative to methyl bromide. However, until the Genera consent is renewed, we will not be able to use EDN in Tauranga, which, as we all know, is one of the larger export ports, because it is not contained in the current Genera consent. MPI, Stimba and the Forest Owners Association are working with trading partners to get acceptance of EDN in the marketplace, and this work continues despite the delays in getting registration. Dual heating is a project that Stimba has been working on for a number of years with University of Canterbury. We have some small projects still ongoing, due to be completed in the next few months, which were designed to de-risk the construction and design of a pilot plant. We've had no success in getting a pilot plant underway. There's a capital cost of between 5 and 10 million in our best estimate, and this is obviously going to be a significant hurdle to overcome. In the long term, I firmly believe that dual heating may well be a potential non-fumigant solution to our phytosanitary challenge for export logs, but equally I am convinced that it is unlikely to be commercialised in the foreseeable future. Debarking has gained in popularity as log exporters have become more and more concerned about the ongoing ability to fumigate logs for export to China and India. A number of exporters have put in debarkers, but unfortunately India is completely unwilling to even discuss the use of debarking as a risk mitigation measure. So debarking is not available as a potential option for exports to India. There has been a significant increase in debarked volume, and we've seen debarkers put in by Timberlands and various other players. They are of various scale and various technologies, and also provide quite variable outcomes in terms of quality. Debarking large cylindrical pruned logs is relatively straightforward, but it becomes more and more problematic as you get into A-grade logs, and then even more so when you get into K-grade, KI, and the small export saw logs, which have branch stubs, are less cylindrical and smaller in volume. There is a possible need for the development of suitable standards to ensure phytosanitary assurance is able to be given to our trading partners. So in looking at the conclusions, our export log trade now faces considerable risk of serious dislocation and of cost increases. Some of those cost increases will come about as a result of not being able to fully load ships if we don't have fumigated logs to go as topstow. We will have to only carry underdeck cargoes or debarked cargoes, and that will in turn mean more ships required, greater congestion on the ports, and more cost. Importantly, if we do not have access to methyl bromide and we haven't got EDN over the line, the trade with India ceases, as they will not accept phosphine or debarking as a suitable treatment or mitigation measure. The failure of regulators to engage strategically and to communicate and to make timely decisions has resulted in substantial uncertainty and leaves us in the position where we are now, with several $1 billion worth of export logs a year are under threat. Controls proposed by EPA in their staff report on the methyl bromide reassessment have the potential, as I noted before, to replace one unworkable control with another equally unjustified, unsubstantiated by science, and unworkable control. It is highly probable that Stimba will continue to seek waivers to extend the period of use for methyl bromide until such time as we have certainty about both the reassessment and EDN, and it is also possible that we will seek further judicial reviews or appeal decisions made based on what we are currently hearing. EDN approvals have not been delivered in a timely fashion by either WorkSafe or the EPA, and this in turn has prevented a possible transition away from methyl bromide. The possible option of a non-fumigant treatment in the form of dual heating remains a long way off and is clearly not going to resolve our present challenges. And that's the good news. The bad news is that we could well end up a bit like the guy in the photograph in having to process substantially more logs in New Zealand, and I'm not sure that we have an efficient system to do that. Thank you for your time, and I'm hopeful that we can find a resolution to this as soon as possible.